Beats per minute play an important role in any type of music. Pop songs have around 120 beats per minute, while trance music has a maximum of 155 beats per minute. When you have to mix two songs together, it will be necessary to know the BPM. This time I will use my Thibaut EM1000 to count the BPM of any song. For this project I'm using a prototyping board from Thibaut instead of Arduino. In next video I will compare both boards so you can decide for yourself whether the Thibaut or the Arduino suits you the best. Today I will only tell you why the Thibaut EM1000 is a great board for this project. The Thibaut EM1000 can't be hooked up to the computer using a USB cable. It's connected via the internet cable. Also, the Thibaut IDE has an integrated file for output on the internet, which makes this project a little bit easier. One of the main differences between the Arduino and Thibaut IDE that I want to stress is that the Thibaut uses BASIC to program the board, while the Arduino has its own version of the programming language C. You can see this difference of the code later on, when I will show you the code we are using. All the pins of our Thibaut board are aligned in these two rows of pins. In this document you can see which pin number corresponds to which pin. You can find this document in the description bar. The Thibaut processing chip is powerful enough to detect the BPM of a song and host it real time on the internet page. Therefore, this is why I choose the Thibaut board for this specific project. But don't be afraid, I will keep uploading Arduino projects as well. Let's take a look at the components that we need for this project. The sound impact sensor will count the number of beats of a song. The sensor is connected to the Thibaut board via jumper wires. The red wire is connected to the power supply pin. The black wire goes to ground and the green wire is our signal wire. The green wire is connected to pin 0. You can check this in the document underneath the video. The processor measures the time played and counts the number of beats. In the code we will create a function that will use these two variables to calculate the BPM of the song. The code we are using is divided in three parts. At the top you can see that we have a main folder, an index.html folder and a global folder. We define most of the code in the main folder and use the index.html folder to host the BPM on the internet page. All the variables are defined in the main folder, as you can see. They are stated as a public variable so that the global folder also knows the existence of these variables. In the global folder we now declare all the variables so that the index.html folder also knows the existence of these variables. In line 12 up to 21, we write that when the sound impact sensor makes pin 0 high, the beat value will also be high. And when the beat value becomes high, the music has played one beat. Therefore, one beat is added to beat number. Line 17 is only read the first time the Thibaut device starts up, because only then intertime is 0 and directly afterwards, in line 18, intertime gets a value and will no longer be 0. We use the variable intertime because we can define time in line 47 as time minus intertime, so that time starts to run exactly at the moment the first beat is heard. In line 28, we created the function beats divided that will calculate the BPM. Lines 32 to 39 tell us that when there aren't any beats for 6 seconds in a row, everything will be set to 0 again, because there might be a new song starting to play. Lines 46 to 49 are the calculating parts of this function that measures the BPM. Line 47 is only needed to make sure that the BPM will never be less than 0. You can see that in line 76 the BPM equals beats divided. Now we go to the index.html folder. Here you can see the standard structure of any HTML page, the head and the body. Lines 18 up to 27 enable us to have the BPM sent to the internet page. Download the code in the description bar below. Upload it and see what happens.